Hello. I hope it is visible. Eh, Hello, hello. We got like three challenges here today. Mm, Yeah, this one I got from a friend. This one is which I made, and this is something someone sent me. Is there anyone? So yeah, I will be doing the challenge I made first, which is just challenge. So if we execute it, like it asks for the magic words, which I don't know. I'm gonna pretend I don't know. Like so, if say subscribe, yep, it says nope. Mm, just try some random things. Yeah, no one is watching. So yeah, basically what I like to do is, let me just open Sublime text. Yeah, whenever I get a binary, I will first run strings command, which will basically get whichever the debug output is there in the binary. So if we check on file, it is help executable, means it can be executed on Linux. So and it is not stripped, which means that the debug information is still in there, like the function names or whatever is there, like the function names, variable names, or it can be anything. So first I run strings command. Let me just run it, and you can see like these are all the strings present at it is in the binary. And yeah, these are basically just libc and all that, we don't care. And yeah, this is in using debuggers, no way, say the magic word, and this looks like the colored output, escape characters and all that. Nope and correct. Well, basically we can't see, at least in this binary flag here, or in our case magic words, but many cases or many ctf has like flag here somewhere or at the end of binary. So it is worth checking, like it takes just a second to check. And if this didn't work, I move to ltrace. Let me just zoom in. So it's visible clearly. Yeah, so if I run ltrace on it, yeah, so basically I can't attach debugger to this binary. Why? Because there are some, like we can make our binary already attached to a binaries, so no other debugger can be attached. Even if I tried attaching gdb to this binary, it won't get attached. We will see about that later. So yeah, basically we use ltrace, so we can see calls like uh, what is called string compare. If there is call of library calls like string compare, we can see it like in ltrace output, so we can basically determine from that. So let me just try running it on another challenge. Yeah, like it is calling puts, so we are seeing it like this. If it was calling string compare function, we will be seeing string compare here. And yep, we can basically get the flag or password from there. So but in our case ltrace didn't seem to work. Now I have two options, like GDBs or Cladari are to analyze the binary. For they are used they are debuggers, so mostly used for dynamic, or I will run Ghidra or IDA, which I have for static analysis. But we can use GDB and Radar 2 for static analysis also. So yeah, first give it a try, and then this, because they are like heavyweight. It will take a lot of resources. So basically, I will be going to use Ghidra or Radar 2, basically R2. So yeah, if you want to, if you want me to try any particular like GDB or R2, let me just know in comments which one shall I use. Yeah, I don't, there may be delay in stream, so yeah, just put in comments GDB or R2. I think I have both. No, I only have GDB. I don't have it. I just checked. I don't have it. Yeah, let's just install it. Radar 2. Yes, install. Till then we will try in GDB. So yep, we can see both of them. So what we will do is GDB and then the name of binary. I'm not no scam. It's not in this directory. Yep. So let me just minimize it so you can see it more clearly. Yeah. So here we are inside GDB. So we can run file command, which generally gives the what is executable and symbols present, but in our case, as we saw in LTRS, we are not letting debuggers attach, so GDB can't attach it to see the file executable and all that. But we can try to like info functions. See, there is no information on functions. Let me just try it again. Info functions in, I can't type. Yeah, this time it worked somehow. But basically, yeah, we can see by running info functions, we can see what are the defined functions, and these are just like standard C stuff. We don't care. We are more interested in main function. We can disassemble it by like disassemble main, and yeah, it disassembled main, but the assembly syntax is not what we want. We want Intel, not AT&T. So we can say like set disassembly flavor to Intel, and now you can see the assembly syntax is much more clear in Intel. At least I think so. So yeah, this is basically just stack setup, and ptrace main. Here we are printf exit. We are more interested in calls to compare, because that's what gonna compare like. So yeah, here is one call to compare, and yeah, here this one is more interesting. It is compare. So if you see this one compare, it just compares the this value with 0x11, and if you see, I can't type 0x11, which is 17. So basically, which means that, and if it's less, JLE means jump if less than or equal. So basically this loop is going to execute from So where it is jumping 147, like here, exactly here. Mouse, no. Yeah, 147 here, it will jump here. So basically this part of code from 147 to 223 is going to execute for 18 times, because it is jump less than or equal to, so we are counting 17 from 0 to 17, so total 18 times. So we can guess, and here is compare, so we can assume that this part of the function, and you can see here clearly username, because debug information was there, so it is having all the stuff here only. We can see clearly that this part, this is the loop which will be comparing our what we say, username or whatever the magic words we are giving it. And so let's see what it is doing. It is first loading the resources like username, and then first it XOR it with 4, like 0x4, and then add it with 0x8. Whenever I'm like analyzing, I don't pay much more attention to like move zx, move sx, which they are basically just arranging the bytes, like ax, the lower part of ax, which is al, higher part is ah. They are just basically arranging the bytes, so I don't really focus on like what this call is doing. Our main objective is to find the magic words or username, whatever we can say, which is here. First we take a byte, XOR it with 0x4, and then add 0x8 to it, and then compare with the byte which is in ex. And what is in ex? It is from this address, like from rbp. Let me just try to see if we can. No, so here we can't see, because we have not loaded the file or executed it. We, some for some reasons we can't see any stack variables here, or maybe there is a way, I don't know, to be honest. So this is the basic idea, so let me note it down here. So first take input, and for every character XOR plus XOR with 4, and then we are adding 8. This is how we are doing it. So yeah, I think this is enough for Ghidra. Let me quit it, and then I hope R2 is installed. No, yes, R2 is installed. So yeah, we can say, like, instead of running R2 and then saying AAA for like analyze, all that, we can just supply the flags like -d for debug, -a for analyze, and then binary, which is our challenge. Can't find function entry. This keeps breaking. I don't know why. For me, radar to always keep breaking. Let me. So I don't want to waste time for now. For now, let's just open Ghidra and try this binary first. Let's complete this, and then we will see about R2. So I have Ghidra installed. Yep, let me open. I made arrangement so that I can see the chat, but no one is in chat today. Last time when I was not watching the chat, lot of people were there. I want to make a new project, non-shared project. Yeah, make it in here. Is it? Yeah, make it here. Name it challenge stream, doesn't matter. Yeah, and then we can just select it and click on I, so it will know we have to import a binary early stream and then challenge. Okay, we are now analyzing it. Okay, just open it. Let me yes, we want to analyze it. Till then, let me just post on Discord. Yeah, I'm from future. Yep, so you can see our code is analyzed. Let's take a look at functions and main function. You can see like it just generated the pseudo C code, and let me just copy it so you can see it clearly. Copy, and yes, this is what it is doing. Yeah, you can see here the first line, p trace me. This is the one because of which we can't attach debuggers. You can see like here, if it is attached, we try to attach the pretrace here. If it is already attached to a debugger, it just exits here. So that is why we were not able to attach ltrace or Ghidra. Sorry, Ghidra, not GDB. Yep. So we ask for input, and yeah, this is what we are doing to our input. And yeah, also keep in mind when you are looking for Ghidra code, just don't look at these castings. Don't pay much attention to this. Generally, I'm not saying all the time, but generally, like star in star, we don't really care here. For now, we are more concerned about what it is doing. So for it is taking local 28, local 2c. Local 2c is like this counter. So we can just replace what it is. It's local 2c, right? Replace local 2c with I. Replace. Yep, this is basically just the return for every character. It is XORing it with 4 and then adding 8 to it. But yeah, where it is taking username from, we are more interested in this username variable we want to see. So hello, yeah, sorry. So if you double click on username in Ghidra, it will just take it where it is defined. You can see here it is defined. Like let me just copy it. No, first you can see it like starts here 00079 0006e. It is basically like that because we are storing a byte in array of integers. So like integer take 4 byte space, so it is just filling the rest of space with 0 and just storing 1 byte. This is because we are using arrays to store it. Bye bye, take care. So we can just select this part. This is what we are interested in. Left click, copy special, and then we can copy as byte string. Okay, So let me paste the byte strings here. Yeah, these are the byte strings. So I don't want that zeros, so let me just remove those zeros. Yep, so replace zeros with nothing, just remove them. So how many characters got? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. Yeah, 18 character, and we knew that our password was of magic words were of 18 character. So yeah, this seems to be about right. Let's just remove the two spaces and make it comma space, replace all. I will make it like this, so it will be, you can just copy it like a Python array, or at least call it in Python. And let me let's make a script like sublime solver.py, and our username like this. And yeah, I forgot, we have to add 0x at the beginning of it. Can do it with control replace, but just do it manually, not much work. Yep, now let me just check if I got it correct. So for now, let's just print it. Yeah, it is working. Yo, welcome to the stream of the, like half of it is over. So yeah, we got the username, and we don't need this anymore. You can see the main function here. We are doing like character XORing it with 8 to get our result. So we want to, yeah, welcome Aksh. I was waiting for him. That was so dead. So we want to like we want to get character from result. So we are adding 8. So we need to first subtract it. Like if you know maths, from we are moving from left hand side to right hand side. Just let me just make it more clear. It will be, we are just moving this from left hand side to right hand side. Here we have to first subtract 8 from the result. And now if you know about XOR, when we XOR A with B and get C, it is, if we, and then basically it is same, like we XOR A with B and get C, then if we XOR C with A, we will get B back again. Here A is our character, we just want to interchange it. So which I mean is like our character will be this part XORed with 4. Yeah. So for every character in this which was stored on stack, we just want to subtract 8 and then XOR with it 4, and we will get the original in. So yeah, let me just say magic words were empty string for now, and then we iterate over each character, and for each character our yeah, for simplicity let's just do this. We want to subtract 8. Let's just try to do it in multiple lines. First we subtract 8 and then we XOR with 4, and I equal to I XOR. And now we want to append, we want to add the character at the whatever the value is. Now let's just print the magic word. Yep, we got it. Let's verify it. Not challenge, it's called challenge. Yeah, yep, these are the correct magic words. This is like very easy challenge where we just need to do XOR. Many times there is like AND operator or operator and you have to figure the bits and all that. I asked for binaries but no one gave me. So yeah, this was the solution for the first challenge. Now let's try the next one, which is this a byte. I think this one is also similar to our current one. We will follow the same methodology, like first strings, then try ltrace, then we will try GDB, or just then we will directly go to Ghidra. So yes, minimize, let me minimize it and close this project. No, I don't want to save it. Yeah. And first let me run it to see what it is. A byte. You do not know the yes, so it doesn't ask for input, so maybe it is taking some argument. No, that's not the case. So let's just try strings on it. Yeah, you can see that this string we saw in output, and oof, you're too good. We want to get to this string, I suppose. And seeing strings, one more benefit is that you know that this string was printed, so it might be the part of main function. So if there is no naming in the function, you can identify our main function by it. Now if we try ltrace, yeah, it's not calling any string compare, only giving call to put, so yep, we can't see anything there. We can spend time in GDB, but let's just hop into Ghidra and import it. Analyze it. Open it. Yes. It's so silent. Yeah, let's see in function now. Yeah, this is what I was talking about. I don't know whether you are able to see it or not, but you can see here there is no function named as main. We have to identify which of these is main function. One thing is that we can go to entry function, and in entry function the first argument passing to the libc start main is the main function. So we know that 73a is the main function. If you just double click, and yeah, this is the main function. We can tell it by this also. As I told you before, we can identify the main function with this also. But general easy trick is just to go to entry function, and the first parameter to the libc start main is our main function. Just it is very handy trick to know. And yeah, it is calling string compare to this, I think, and local 38. So yeah, this is basically from here on this code, it is just calling the string compare function, but where it is taking input from? I think it's taking input and then I can't zoom in here, so let me just copy it so you can see it as well. I don't care about all this, just copy, make a new file, paste it here. Yeah, so we just want to, yeah, you are the only one in chat. That is, I don't know, last time I was not seeing the chat, so everyone was here. This time I made a special arrangement so I can see the chat. Now no one is here anyway. So yeah, we just want to make this string compare to run it value. These are the bytes it is comparing to. So this thing, it is comparing our input with this thing, but before comparing, it is checking the string length, and string length should be equal to 0x23. I'm considering you to be here, like I'm not even counting you. I know you will be here. Yeah, so 35. Our string length of the argument should be 35. Then only it will enter this loop. Yeah, I am using the second laptop. I have two laptops. Old laptop for, yeah, no, Drago is rich, not me. So yeah, we can see we first got our length of the flag should be 35. Let's keep it in mind. And we are then iterating over the every character, and you can see here this is our the argument we passed, and it is XORing it with 1. Just to saw, you can just XOR it again with 1 to get the original thing. So yeah, it will take our input, XOR it with 1, and then compare with these bytes. So let me just copy these bytes. This challenge is almost solved. And let me just try to do some regex stuff if I can. Turn on the regex from here. Just replace this all stuff. I know there is better regex, but yeah, for now let's just do this thing, replace all. Yep, easy. And for I, let me check what I is in hex, so we can do this by transparency. Okay, where it is, I don't know where it was. Yeah, so found it. References. I hope this should be fine. Sorry about it. So yeah, we can do it like hex and then order of I. It is, yeah, saw that. Let me just put it here. And I don't, yeah, stream is delayed, so you are seeing it late. Let's make another file, a byte solution.py, and let's make our I'm assuming this is like CTF flag or something. I don't speak super rich English. I'm learning from you, Olympiad champions. Yeah, it is VM. Mint. Linux Mint. So yeah, for every character in flag, let's just rename it F and our flag as flag. We just want to XOR it with 1. So I think this should work like, and then flag plus equal to everyone is coming like for some time. Yeah, nice. Work is almost over. I don't have any more binaries. So yeah, let's try running it. Yes, we got it. Was from hsctf. Wow, you know the V. Let's verify it. Yes, I'm too good, I know. If you have some more binaries, just send it to me. We still have time. So we had like 2 binaries which both we solved, like a byte and challenge. This binary is, I hope this guy was it just like, it is from Tenacious, the CTF team which I was in. So yeah, not close without saving, close without saving. This is just the methodology. Most of the time I just skip GDB and R2, because you can see like the pseudo code, so you don't have to try hard to understand assembly codes and loops when you are not experienced in it, or at least have done it before. It's so pain if you don't know what it is. It is very simple to see, like it's calling string compare and running a for loop. Like, so if I highlight this, if you know this, if you know assembly, then you could have like, wherever there is jump place and compare call one after another, there is usually a loop. So this is the highlighted part which is in loop. That's why Ghidra come in handy, like it generates pseudo C code, so we can focus on the C code to do this. And let me show you the source code of the challenge which I did. This was the source code of first challenge. This is what I was talking about. We tried to attach the p trace to our binary, and if we fail in it, which means that the tracing is already being used by trace or GDB or some debugger, we just exit the binary from that point. This is just little trick which can prevent from someone attaching debugger to your binary. I don't know how realistic is that. Yeah, just make reverse engineering harder. You can, other ways that you can just decompile binary, patch, replace this much function with no or something, like patch it, and there are workarounds around that, but yeah, for now we don't need it. And indeed it was the same thing. So we solved both of the binaries. Yeah, save it. Yeah, if you have anything in chat, let me know. Just where it is, I lost the flag. Right on 3. This is the flag for first one. This was the thing, and this was not. I just went for which code? No, that was other file. You joined stream late. These are different. I was showing the source code of the file. Source code of the challenge I did. The first challenge I did. It is C. That is Python. Do you have any binaries? You can send me, like, I can download it then and try doing them if you have any. Or just anything general to say in chat. Yeah, let me just wait a minute and do you have any binaries? I'm like, this is all I have, all I had. What fun. I went to open chat. Hey, hello. So my name is Swanand. You can say it. If you say it slowly, like it's Swanand. If you say it fast, it's Swanand. Anything. Yes. And this was just the file from my CTF team 10 HES, which I was part when I was playing CTFs. Yeah, finally you are able to hear my name's pronunciation. I was waiting for you to join the stream. Yeah, that's it. If you have challenges, just send over to me. Or I was going to do from, this site called malwaretech.com. These are Windows executable, but like these are easy, very easy one. No, my name is just Swanand. I don't know. Yeah, there are reversing challenges like this here on this side, but it's like all static analysis. So yeah, so which are easy, like I did them before, like strings and shellcode, ransomware. These are some easy ones. That's why I was asking in the server. So if you have something, send it over as a challenge. I'm ready to do it. It will be fun. And I think that is it. That is almost it for today, because we didn't put all the challenges we had. I had like only 3. So yeah, solved it using Ghidra and then Python script for just decoding the bytes and the reversing. And this is just the methodology. This is how I did it. And this is generally how I do it. I think there are challenges like rave me's and all that. I like some custom challenges, like you send me and I will try to reverse engineer it. Yeah, if you have anything to say, just say in chat. It's just yep. So I think that's it. I will end the stream then. Thank you for for being here. Let's see. Let's just yeah, thank you for watching. I'm ending. You can just join the server, Discord server, if you have to say anything or chat like in general. Bye bye. Shit. I'll end the stream.